In this video, we are going to solve the Leetcode problem of the day, and the problem is partition labels. First of all, let me explain you the problem, and then we will understand what is the approach to solve this particular problem, what is the intuition behind that approach, and then we will code our solution in Python. Okay, let us understand the partition labels question. In this particular problem, we have one input. This is a string, and right now this is the example number 1 whose length is 24. The output for this input should be 9, 7, 8, and you will notice that the sum of these numbers is equal to the length of the string. Now what is the task based on what we are going to create our output? So the first thing is we need to partition the string. So we have a string and we need to create partitions of this string. Okay, this is one partition, this is another partition. Like this we need to create some partition. The partition should be continuous, so it is not like you can take some part from here and some part from here, concatenate this and call this a partition. No, it has to be continuous. So this can be a partition, this can be a partition, this can be a partition. So the first point is partition the string. The second point is we need to maximize the number of partition. We need to try to make more number of partitions, the maximum number of partitions. Okay, so instead of making partitions like 1 or 2, you try to maximize your partitions, like okay, 1 partition, 2 partition, 3 partition, 4 partition, and more number of partitions. But the rule is each letter should be part of one partition. Our string is having lowercase alphabet letters A, B, or D. All these letters are here. We need to make sure that when we partition our string, okay, let's say we make two partition for now. So first partition can have some characters and second partition can have some characters. One particular letter should be part of just one partition. For example, if I am partitioning my string here, then you will find that this partition is having A, B, C. But I can have another partition right now which will have A or B, or C. So in that case, I cannot partition my string at this point. This is not a valid partition. So we need to create valid partitions and maximize the number of partitions following this particular rule that each letter should be part of one partition. What we need to return is, we need to return the length of each partition. So right now the length is 9, 7 and 8. It means if you start from beginning and try to fetch the first 9 letters, these are the first 9 letters, then this is one partition in which all the characters are just part of this particular partition. So now let me zoom a bit and try to explain you how this input right now is producing this output. So we know that the output we need to return is the length of each partition. So right now the output is 9, 7 and 8. It means we have 3 number of partitions for this particular string and their lengths are 9, 7 and then 8. So 9 means that since 9 is the first partition, it means start from beginning and go till the 9 characters. So this is the 9th character right now, and here you will notice that none of the characters which are there in this partition is also part of any other place in the string. So this particular first partition is made up of A, B and C, and you will not find A, B and C in any of the other part in the string. So that is why this is a valid partition whose length is 9. After we have processed 9, let us understand how the output is 7. So let us take the next 7 characters. So these are the next 7 characters from D to E. Now from D to E, this part of the string you will find that D, E, F, E, G, D, E. So it is made of D, E, F and G. So these characters D, E, F, G is just part of this place in the string, right? You will not find it anywhere else in the string. So this is a valid partition. 7 is the length. Now we also know that we need to maximize the number of partition. But you will notice that if you try to break any of the existing partition in two parts to maximize or increase the number of partitions, it will become invalid. If you break it here, you will find that A is part of this partition and A is part of this partition. In the second one also you will notice that if you try to break it here, E will be part of both the partitions, 2 or more partitions, right? So we need to follow the rule, each letter should be part of one partition. Now let us see the next one as well, the next 8 characters. So starting from H, you will go till J, and you will find that this is the last partition which is valid. So we have 1, 2 and 3 partitions and the lengths are 9, 7 and 8. Alright, so now since we understood how this particular input is producing this output, let us try to understand what can be the intuition behind this particular problem and how to approach the solution for this particular problem. So right now what you see on the screen is the same string which we have in the input in a list format. Now what can be my first thought when I am trying to understand or trying to solve this problem? The first thought is I have to partition the string and I have to maximize the number of partition. Forget about the rule number 3 for now. Just focus on the first two rules. Let me partition and let me maximize the partition number. Okay. So what can be the maximum number of partitions? So right now I can see my string is having total 24 characters. So the maximum number of partitions I can create is 24. That's the max I can create, right? For example, every character itself can be a partition. Okay. So 1 partition, 2 partition, 3 partitions. If you try to create the partition of every character, then the total number of partition will be length of the string. So right now it is 24. But now we have another rule that each letter should be part of one partition. So if you try to create the first partition, let us try to create the first partition, this A, okay? And you said that, hey, I have a partition in which A is my only letter, which is at index number 0, and its length is 1. Is it valid? No, it is not valid. The reason is, if you try to create this particular partition, you will find that this particular value A is here as well, and is here as well. So when you are trying to create a partition which is starting from A, you will have to create a partition whose minimum length is from this starting place till this ending place. You will have to include all the A in your partition. So what this is telling me is that if you start from the first character, which is A right now, then in that case this is not valid. But what I can do is I can increase the size of my partition, which was starting from A, which was at index number 0, to this particular A. This is the last A I am having in my string. So I will have to start from the index number 0 and go till the A, which is at index number 8. Now right now this can be a valid partition. This can be or may not be. And the reason for this is the character A is fine. Okay, we are starting from this place going to this place. So we know that this particular partition will only have the character A. None of the other partition can have the character A, because this is the last time I found A in my string. Alright, we are good with A. But what about this B? Your partition is also having another character called as B. So you need to make sure that the other characters which are there in your partition, those should also be the part of your own partition. So B is here, B should not be here. So right now in this example, B is not anywhere else. So this is also valid. Okay. But think about this. If we have a B here as well, okay, at index number 15. So in that case, this partition will not be valid. Although for a character A, it is valid, but it is not valid for all the characters. So from this particular thought, I came to a conclusion that I will have to ask each of the characters which are there in my string that what is your starting limit and what is your ending limit. Where are you starting and where are you ending? For example, if you ask A, which is the first character, it will say that I will start from the index number 0 and I am going till index number 8. Okay, so my range is 0 to 8, and this data is telling me that you cannot create more than one partition starting from index number 0 and ending at index number 8, because if you try to break this particular range, it will have two partitions, and for character A the rule will break. It will be part of two partitions. Okay, I got a data from A. What is my next character? It is B. So I will ask B, what is your range? So B is telling me that I am starting from this index 1. Okay, so my starting index is 1 and I am going till index number 5. So index number 5. Now this particular data is telling me that you cannot create more than one partition starting from index number 1 and ending till index number 5, which means that I will have to create a minimum partition of this particular size. Now I already knew from A that I cannot break my partition starting from index number 0 to index number 8. So this data is not telling me any new information, because I already know that from 0 to 8 I cannot break my partition, or I cannot break my string. But okay, I got a data from B and we can ignore it safely, because we know that we are starting from index number 0 and ending to index number 8. We cannot create more than one partition, and this is just telling me a range which is already inside my current range 0 to 8. So we can safely ignore this information, and right now we just know that I can create one partition from 0 to 8. The other characters are going to tell us about the other range as well. Now what about the next character, which is A? So we already have an information for A, so we can ignore this. What about B? Already we have information about it, we can again ignore this. But what about C? We don't have information about C, so let us start having the information about C. C is telling me that it is starting at index number 4 and it is going till index number 7. So C is starting from index number 4 to 7, and the meaning of this is you cannot have more partitions in this range. But again, this is a redundant information, because I already know that I cannot create more partitions in the range 0 to 8. Okay, so again we can safely ignore this information, and 0 to 8 is our one partition for now. Now what about the next character, which is B? We already have information. A we already have information, and C we already have information, and for A we already have information. So we are going to ignore these four characters. But next, when you came at this character, which is character D, the character D, what it is telling me, it is telling that I am starting at index number 9 and I am going till index number 14. This means that D is telling me you can create a partition from 9 to 14, but you cannot break your partition from in this range. But this is a one valid partition according to D. And now this range is out of my existing range, right? 0 to 8 is one range, 9 to 14 is a different range. So now I know that my first partition should be from 0 to 8, and the length of this will be 9, right? Since it is starting from index number 0, you go till index number 8, so it will be 1 plus all the 8 other characters, 9 characters, right? And you will notice that our first output is 9. So this was the thing, how we produced the output as 9. So right now we are good with our first partition. What about D? D is telling me 9 to 14 is one partition, but let us see what other characters are telling me. So let us look at the next character, which is E. So what is E telling me? E is telling me I am starting at index number 10 and I am going till index number 15, 10 to 15. Now here is a very important thing to understand. D is telling to create one group or one partition from this place to this place. This is the one partition, right? 9 to 14 according to D. But E is telling that the partition should be starting from index 10 to index 15, right? This is a partition according to character E. So here we know that I cannot create more partition in range 9 to 14, but E is telling me that till 15 you cannot create more partition if you are starting from index number 10. So in that case we are going to merge their information, and the information after getting merged, this will be 9 to 15 is something we cannot create more partition, because that is simple, right? We start from 9, we go till 15, then E and E both will be happy. We can create one partition from 9 to 15, but if you try to break it anywhere, either D or E will not be happy about this. Okay, if I break it here, then E will be here as well and E will be here as well, so they will not be happy. So if you are not happy, I will create one partition which is the merging of your informations. Now let us talk about the next character, which is F. So F is telling me that start from index number 11 and go till index number 11. Since this F is only one time, the range is 11 and 11, right? We don't have F anywhere else. So according to F, you can create this as a single partition. This is what F is telling me, but this 11 comes in our existing range, so no new information from F. What is the next character? It is E. We already have information for E. You can ignore this. What about G? Well, G is almost similar to what F is telling me. G is telling me start from index number 13 and go till index number 13, because this is just one time in our string. So again, we can safely ignore this information. The reason is this range is inside our existing range. So no new information, right? What about the next character? The next character is D. The next character is D, right? We already have information about D, so we can ignore it. And E, we can ignore it. What about H, which is the next character? It is telling me that I am starting at index number 16 and I am going till index number 19. This is 19, okay? Start from 16, go till 19. Now this is a new information. You will see that your existing range is not conflicting with this range. 9 to 15 is we are ending, and this is another separate range, right? 16 to 19. So I can definitely create a partition of this range. 9 to 15, you will see that 15 minus 9 plus 1, this is equal to 7. This is the length of this particular range, and 7 is your next output. So we have 9 and we have 7. What about 8? Well, the formula is going to be same, so I'm not going to go character by character, but the formula is going to be same. When you find for H, it will tell you 16 to 19. When you find for I, it will tell you 17 to 22. So right now, just let me tell you about I. I is 17 to 22. So since this starting range is within your existing range and the new end should be 22, right? So this will be merged and this will be equal to 16 to 22. So this is your one range in which you can create a partition. You can create, but you will create or not, other characters will tell you, right? So when you go and try to find for all the other characters, you will find that this range is increased from 16 to 22 to 16 to 23. And if you see 23 minus 16 plus 1, this is the length of the range. This will be equal to 8, which is our third output. So this is how we are going to solve this. We are just going to ask each character what is your range, and we are going to merge our range. And the moment we saw a new range, a new starting point, which is more than our ending point, the last ending point we had, we are just going to say the last partition is one partition. Now I have a new partition, a new valid partition. So now since we know what is the approach, let us start solving this particular problem using Python in our code editor. So first of all, let us create two data dictionary, st and end. In st, we are going to store what is the starting index for each character, and in end, we are going to store what is the end index of each character. So I comma c in enumerate s, this will give me the index and the character for each of the character in my string. So end of c should be equal to I. Now this will assign the last index of each character. What about the starting index? We are just going to assign it one time. So if c is not in st, so in that case st of c is going to be I. So st is going to store the starting index, end is going to store the ending index of each character. Now let us create a result. Result is equal to empty list. Now convert your data dictionary into list, st.values, because now we just need the indexes and we don't need the actual character value. So let us take that value list and convert it to list. Do it for end as well. So end is equal to end.values. Now let us store the current range. So my current starting range is equal to st of 0 and my current ending range is equal to end of 0. This is my first partition. I'm assuming that this is my first partition. Right now I'm not pushing it to my result. Next, run a loop for s comma e in zip your data st and end, and then check a condition that if the new starting range which I found, if that is more than the current end range, then I know that I can create another partition. So result dot append is the last partition which you had, current end minus current start plus 1, and update your current start, which is should be equal to start, and current end should be equal to end. And now when you come out of this condition may or may not be true, but every time you will have to update your current ending value, which should be equal to the maximum of the new ending which you got and the existing current end. Okay, so this is to make sure that if you need to widen your partition, then this current end is going to be updated. And when you are coming out of the loop, you will notice that the last partition data is not appended because we came out of the loop. So let us append that data. Result dot append the last partition data current end minus current start plus 1. And once you are done, just return the value of result, and that's it. Submit your code and you will find that this is the perfect code for this particular problem. Yes, and you will find that this is a pretty efficient solution as well, right? We are having a runtime of 96% and memory of 14%. And I have used the same code earlier as well, and you will find that it was 0 ms and 17.7 MB, which is like 85% of memory, and runtime is 100%. So this is a pretty efficient solution for this particular problem. Let me show you the complete code. So this is the complete code. Yeah, this is the complete code. So I hope you liked the explanation of this particular problem and the approach to solve this particular problem. And if you did, then please hit that like button. And also, if you are new to the channel, subscribe to my channel as well. I'm uploading Leetcode problem of the day every day, so that you can find the approach and the solution as well. So make sure you subscribe my channel as well. And that's it for this video, guys. I will see you guys in the next video. Thank you for watching this video.